Unit 10, moles and stoichiometry. So, stoichiometry is really just the study of the amounts of reactants and products in a chemical reaction. It's pretty much like cooking. It's the chemical recipe. So we're going to review counting atoms. Remember, the subscripts indicate the number of atoms in the formula. The coefficients are the total number of molecules or compounds. So if we look here at 3 calcium phosphates, we actually have a total of 9 calciums, a total of 1 times 2, which is 2, times 3 to give me 6 phosphorus. Then we have 4 times 2, which is 8, times 3, which is 24 oxygens. So we're going to practice. How many oxygen atoms are in each of the compounds below? So ammonium nitrate has how many oxygen atoms? The answer should be 3. For C3H8O4, we should have a total of 4 oxygen atoms. And for ozone, we have 3 oxygens. And C3H5NO3, there's a total of 9 oxygen atoms. So, the mole. The mole is basically a unit of measurement to kind of tell us the amount or the number of particles in a particular substance. The number 6.02 times 10 to the 23 particles is basically telling us that in 1 mole we have this many atoms of that particular element. So 1 mole equals the gram formula mass. So, why do we use it? Atoms are so very tiny that we need a lot of them in a given sample to have it be useful. So we do a lot of counting, such as a dozen is 12 eggs. A mole of eggs would be 6.02 times 10 to the 23rd eggs. So one of the things that we can do is we do this already. It's just that now we're going to do it with a very large number. So if I have 3.5 dozen roses, I know that each dozen is 12. I take 3.5 times 12 and I know I have 42 roses. It's the same thing with moles. The molar mass, or also known as the gram formula mass or molecular mass, is the mass of the formula expressed in grams, and it will be equal to 1 mole. So we'll get used to seeing this unit here, grams per mole. You can either spell mole M-O-L-E or M-O-L. Elements' molar mass are on the periodic table, so the mass for the elements is actually with the unit, grams per mole. So to calculate the molar mass, we're going to count the atoms in the compound. We'll look up the mass for each atom on the periodic table. We'll multiply the mass by the number of atoms of each atom and then add up the total masses. So for example, the molar mass of iron is 55.847 grams per mole, and then the molar mass for copper is 63.546 grams per mole. So now we're going to practice actually calculating the molar mass of compounds. So what's the molar mass of water? Well, the formula for water is H2O, and I have 2 hydrogens, each with 1 gram per mole, plus 1 oxygen at 16 grams per mole, for a total of 18 grams per mole. What's the molar mass of calcium chloride? Well, calcium chloride is 1 calcium atom and 2 chlorines. So 1 calcium is 40 grams per mole plus 2 times the mass of chlorine, which is 35.5 grams per mole. Add those numbers up and you get 105 grams per mole of calcium chloride. So let's practice. What's the molar mass of calcium? Well, if we look on our periodic table, calcium has a mass of 40 grams. There's 1 atom, so 1 times 40 is 40 grams per mole. What's the molar mass of bromine? Bromine is diatomic, so we need to actually take 2 times the mass of a bromine atom for a total of 159.8 grams per mole. So here's the molar mass for carbon dioxide. 1 carbon with a mass of 12 grams per mole plus 2 oxygen atoms at 16 grams per mole. Add the numbers up and we get 44 grams per mole for 1 carbon dioxide molecule. So your chance to